In this next example, we'll look at some formulas that we can use to compute the mean, the variance, and standard deviations. The mean here is given by the formula of the sum of all the x times p of x. In other words, we're multiplying each of the x values of our random variable times the probability of that particular x occurring, and then summing those all up. So this is also something later on that we'll also call the expectation, or the expected value. And it's kind of maybe interpreted a little bit differently in that case, but it's exactly the same number. So the mean is the same thing as what we'll call the expected value. The variance is computed by taking here each of the x values from the mean and then squaring that distance, multiplying it by that particular probability. So it's kind of like a weighted sum here, each of the distances from the mean squared times the probabilities. And over here what we see is this is actually maybe an easier way to compute it, and that'll give us the variance. And then to get the standard deviation, we just take the square root of that. And then of course we also have another round off rule, which is similar to what it was in other cases, where we're always going to round to one more decimal place than what we see in the data. In the next slide, we can look at how we can compute these formulas with this particular example. Here, let's blow it up a little. In a study of brand recognition, random groups of 4 people are interviewed. Let X be the number of people who recognize Jeff Bezos when shown a picture. The following probability distribution gives the likelihood of that random variable. So if we're looking at the table, right, they've listed out the values of X between 0 and 4. Here we're looking at a group of 4 people. And so the probability that none of those people recognize Jeff Bezos is 0.01. Probability that one of those people recognizes him is 0.10. And probability that 2 of them recognize him is 0.24, and so on, right? So that's how we can interpret the values here in the table. And of course we know that in order for this to be a proper distribution, the sum of all the probabilities has to equal to 1. So we can just quickly verify that. And yeah, here it is in fact 1. And then to compute the mean over here in the next column, we'll multiply each of these values. 0 times 0.01, of course that'll be 0. To fill in the entries here in the next column. 1 times 0.1 will be 0.1. 2 times 0.24 will be 0.48. 3 times 0.30 will be 0.9. 4 times 0.35 will be 1.4. And then when we sum up all those values, we can get the values down, the sum down here in the bottom, and that'll give us 2.88 as the sum. And actually that also tells us what the mean of our distribution is. So remember, that's our mean. And in the next column, we're summing up all the x squareds times the probability of that x. So again, here we can square each of the x values in the left column and then multiply them by their corresponding probabilities. So that first one, 0 squared is still 0, so that one stays 0. 1 squared is still 1, so that one stays 0.1 when we multiply by 0.1. 2 squared will be 4, so 4 times 0.24 will be 0.96. 3 squared is 9, times 0.3 will be 2.7. 4 squared is 16, times 0.35 will be 5.6. And when we sum up those values, we get 9.36. Now this is going to be useful later on when we compute the variance. So we'll see that in in a minute when we want to compute the variance or the standard deviation. But let's look at the questions below asking about a particular probability. So we can use the table to help us answer some questions about probabilities. What is the probability that more than 2 people will recognize a picture of Jeff Bezos? So we can think of that as the probability that our random variable x is greater than 2. And looking at the table here, well, that would be one of the entries here in the bottom 2, right? So it's either probability that 3 of them recognize Jeff Bezos or the probability that 4 of them, so we can add those together to get the probability that more than 2, so 0.3 plus 0.35 gives me 0.65. Part B, what is the probability that at most 3 people will recognize a picture of Jeff Bezos? So here again, we're thinking at most 3 would mean that x, our random variable x, is less than or equal to 3. One way you could look at that is, here, let's think in the table here. The probability that x is less than or equal to 3 would include all this stuff in the bottom portion of the table. But if we're clever, we can just use the probability, the complement of that. In other words, we can think of this as 1 minus the probability that exactly 4 recognize him. So that would be the complement of the event x is less than or equal to 3. So that's going to be an easier one to compute. We could just do 1 minus 0.35. And again, that leaves me with 0.65. In part C, find the mean number of people who recognize a picture of Jeff Bezos. Actually, we've already computed that above, right? We figured that out right here. So our mean would be 2.88. And the standard deviation, which if you guys remember was sigma equals square root of the sum of the x squared times p of x minus mu squared. So we found the x squared times p of x sum was 9.36 minus the mean squared, which would be 2.88 squared. And that leaves me with something around 1.0322. Or here we can just simply round to 1%.